Recall the formula for compound interest, which is compounded once a year, so that's annually. A equals P times 1 plus R to the T. So A is the future amount, P is the present amount, R is the rate, and T is the number of years. So interest can be compounded more than once a year. So in this case, the formula for compound interest is very similar. What's different is the rate is divided by n, and the number of years is multiplied by n. So those are the two differences, and n is the number of times the interest is compounded each year. So if we have annually, we really don't need to use that formula. We can use the other one, but n equals 1, and you'll see how that is true, that it's exactly equal to this formula as well if n is 1. Semi-annually is twice a year, so n equals 2. Monthly is every month. There's 12 months a year. And quarterly, there's 4 quarters, so n equals 4. These are the common phrases for how many times interest is compounded each year. So our first example here, find the amount owed at the end of 7 years if $2,000 is loaned at a rate of 5% compounded quarterly. So 7 years, 2,000, 5% quarterly. T is the number of years. 2,000 is how much is loaned, so that's the present amount. R is, and it's in decimal form, so 0.05. And quarterly tells us that this is compounded 4 times every year. So let's use our new formula. A equals P times 1 plus R over N raised to the NT. And let's put in what we know. We know that P is $2,000. R is 0.05, N is 4, and T is 7 years. So this is something we can put in our calculator. If you're just using a regular scientific calculator, you'll have to do the division, add 1, raise it to the exponent, and then multiply by 2,000. That's the order of operations there. But if you have a graphing calculator, you can just plug it in the way it is. And that should give you a value of 2831.9846. And this is money. A is the future amount, so we're going to round that to the nearest hundredth. If we look over here, that's a 4, so we stay where we are at 98 cents. So $2,831.98 is owed at the end of 7 years. For number 2, we want to find the amount owed at the end of 7 years if $2,000 is loaned at a rate of 5% compounded monthly. So everything seems to be the same here, except instead of quarterly, now we're doing monthly, so that means n is 12. So we'll use our new formula, P times 1 plus R over N to the N times T. And let's put in what we know. 2,000 is the present amount of the loan. So rate is 0.05, 12 times a year for 7 years. So you can, again, do the division, add 1, raise it to the exponent, and then multiply by 2,000 if you're using a scientific calculator. Otherwise, just put this in your graphing calculator the way that it is. And we should get 2836.0721. Again, it's money, so we're going to round to the nearest hundredth. That'll be $2,836.07 after 7 years. That's how much we'll owe. So, which number of times compounded per year would you prefer if you were borrowing the money and paying that back plus the interest? So 7 years for $2,000, 5% quarterly was $2,831.98. 7 years, $2,000, 5% monthly was $2,836. 6 and 7 cents. Which one would you rather pay back? You would rather pay back the lower amount, right? And remember, the only difference between these two amounts is how many times the interest was compounded. So quarterly, it was compounded less, so the interest was accumulated less than if it were done monthly. However, if you were the one that was borrowing the money to someone else, of course, you would rather they pay you back more interest. So it depends on which side of the loan you're on. Number 3, radioactive debris was released into the environment due to a nuclear accident. The percent Y of radioactive material found in raw milk after T days is modeled by the equation here. Y equals 100 times 2.7 raised to the negative 0.1 T. Estimate the expected percent of radioactive material in raw milk after 10 days and after 90 days. So 2 questions here. It says Y is the percent of radioactive material and T is the number of days. So when they ask us to find the expected percent after 10 days, that's when T is 10. And 90 days is when T is 90. So let's take the equation that we're given that models the percentage of radioactive material found in raw milk. And we'll evaluate this at 10 days to see how much is in the raw milk after 10 days from the exposure. So if you're doing this in a scientific calculator, you probably want to multiply these first and then raise this to that power and then multiply by the 100. That's the order of operations there. Or if you're doing the graphing calculator, you can put it in just the way it is. And this should get you 37.037. Doesn't tell us to round. It says estimate. So an estimate would be about 37% radioactive material in raw milk. And after 90 days, I hope that this is a lot less. Let's see. We'll put 90 in for T and put that into our calculator. And that should be 0.013. So that's not even 1%. Less than 1% radioactive material, which is good after 90 days. Most of that is decreased, so it's a lot safer then.